But you can potentially with gravitational waves, which is this measurement that got the Nobel Prize a couple of years ago, the LIGO experiment here in the United States. And that, see, it looks for ripples in the fabric of space and time. And in principle, if we had a big enough detector, you could see the ripples from the Big Bang. So you could take an image of the Big Bang in gravitational waves, which would be, but you need an enormous sort of space-based detector that we're not going to build anytime soon.
Now, obviously, this is all through equipment and technology that's been invented over the last few hundred years and perfected. Is it possible that things could get better and you could get some ability to detect things even in a far more distant way?
Yeah, I mean, gravitational waves are incredible. I mean, Einstein predicted them in 1915. Never thought they'd be detected because you need such a high, you need lasers. They didn't have lasers. But the thing, LIGO, this experiment, which is half in near Seattle in Washington State and half in Louisiana, so they've got two detectors, and they're basically sort of 3-mile long laser beams that just sit and measure the sort of stretching and squashing of space as the ripples in the fabric of the universe go through. And what they've been observing are collisions of black holes. So you can imagine how extreme, like a colliding black holes. It's an incredibly extreme event. So it shakes the fabric of the universe, and the ripples come across the universe. And these laser beams, which are just basically rulers, can detect it. They just sort of ring almost like, just vibrate as the ripples go through in space and time. Kip Thorne, who got the Nobel Prize last year for this, he's one of the greatest living physicists. So I once saw him describe it as a storm in time. So you've got a time storm. It's a beautiful image. So that technology is incredible because the change in length is, I can't remember the exact number, but it's way, way, way less than the diameter of an atomic nucleus. So the change in length of the beams, it's tiny measurement, but we can do it.